Now we're going to go through and we'll do some deburring. And we're going to do a 2D contour. And on this very first one, all we're going to do is machine this flat here. And we're going to do this as a 3-axis move. And so we're going to use the 1/4 inch flat. And we're going to mill this little face here. So we're going to go to geometry, partial. We're just going to select one edge here. And we're going to have it travel all the way across. It doesn't matter which direction it's going across the part. Now we're going to go to the next tab, and on our heights we're going to leave this stuff at default. I think that's except for the 0.75 on our rapid plane. And then our cutter will come down and just skim the top of this thing. On our heights tab, we're not going to do any compensation. It doesn't really matter. We're not going to do multiple finishing passes. What we are going to do is stock to leave. And on axial, it's going to be 0. But on radial, we're going to go negative point. Let's do negative 100 thou. And then that way, it's going to overcut whatever that line is we selected. Okay, we're going to go to the next tab. And we're going to come in at an approach angle of 0. And we're going to get rid of our vertical lead-in radius. But we need to extend our lead-in distance to 0.26, which is, 0.13, which is half the diameter of the cutter. And when we hit OK, that 1.13 lead-in is this green section. So it's going to lead in and hopefully zip off and deburr this very first top. Okay, now we're going to deburr this edge, which was machined with the very first face mill. We're going to go to 2D. We're going to go to 2D chamfer. We're going to select our 1/4 inch chamfer mill from our library. And leave all the speeds and feeds at default. We're going to go to multi-axis, pick tool orientation. We'll pick the face of the first face we machined and our x-axis. We're going to go to geometry and we're going to select from our menu here our chain, partial chain. We're going to select our one edge here. We're going to hit OK. We're going to go to heights tab. We're going to bump this up to 0.75. We're going to go to the passes tab. We're going to bump our chamfer offset to 0.06. We're going to go to the linking tab. And we're going to leave all this at default except for our lead-in sweep angle is going to be 0. And our linear lead-in distance is going to be 0.13, which is a little bit longer than half the diameter of the cutter. And we're going to deselect perpendicular for this one. And we'll hit OK. It's going to lead in off the workpiece and cut in. All right, so those are all the chamfers that are done 6 times. So what we're going to do is we're going to go to Setup, and we're going to create a new pattern. And this new pattern is going to be a circular pattern. And we're going to select our axis as a cylinder again. And this is going to happen 6 times. We're going to hit OK. And it's going to do this pattern in order by tool. So this is going to be, we're going to rename this pattern our 6X pattern 2. And we're going to drag the 2 routines we just made into that pattern folder. Okay, and we want the tool 3 going first. Okay, and now we can see the patterns going around 6 times. So we've now deburred all those edges. I've chose not to deburr this back edge. It's really hard to control the gouging on it, at least at the time of this recording. It's not worth damaging this part for. So you're going to have to deburr some of these edges by hand. Okay, so next, let's deburr the inside of this oval shaped pocket. We're going to go to 2D chamfer. You're going to use the same tool. We're going to go to tool orientation. We're going to select the box. We're going to pick the same plane we just used and the same x-axis edge. Then we're going to go to geometry and we're going to select the top of the pocket or window, whatever you want to call that, profile. Now we're going to go to the heights tab, bump this up to 0.75. Now we go to the passes tab and we're going to set this also at 0.06. We're going to check the smoothing box. On the linking tab, we're going to leave all this at default and hit OK. Okay, so we now have our deburring on the inside of this feature. Now let's do the deburring on the inside of the diamond shape feature. We're going to do 2D chamfer. Actually, what we can do is let's just copy this routine we just did. So we're going to go duplicate. We're going to go edit. And on the multi-axis tab, we got to clear the face we selected and pick the face with the diamond on it. Then we're going to go to geometry and we're going to clear the geometry that was selected in the previous copy. And now we're going to pick the geometry associated with the diamond. And then on the heights tab, we should be able to leave this at default. Passes, we should be able to leave this at default. And linking tab, everything at default. And now we have the chamfer that occurs on the diamond. Now we can create our pattern. We're going to go setup, new pattern, circular. Our axis is the cylinder. It happens in 3 instances around 360 degrees, and we hit OK. Now we're going to call this our 3x pattern 2. All right, so now we're going to drag our 2 chamfer commands into that folder. Kind of doesn't matter which one order they go in, and you can see now they're duplicated all the way around. You should be able to see that you've got the different pattern folders, and for each of the items labeled how I have it. Okay, we're going to go from manufacturer mode and we're going to go back to our design panel and open up the design panel, and we're going to bring in a version of the vise. We're going to select the 1.5 inch tall parallels, and the reason is the base of this part to this bottom ledge is 1.5 inches. We're actually not going to put the parallels in as shown in the model, but it'll help us assemble this. We're going to hit OK. And we're going to rotate our vise 90 degrees. We're going to move it down below our part. And if we look at from the top view, we need to get the jaws parallel to 2 faces of our part. So we're going to rotate this 30 degrees, and that should get these 2 jaws parallel to the 2 faces of the hex. We're going to hit OK. Now we're going to go to Assemble, and we're going to do a joint. And we're going to do that joint in between the top center of the 1.5" parallel and the bottom center of our part, which should snuck it in like this. Now, in reality, we're going to have the bottom of this part on the bottom of the vise jaw, and then we won't put parallels in. Okay, we'll hit OK. In the reality, we may need to put a parallel flat on the bottom, and it'll be sitting 1 parallel thickness high. That's okay because our origin is going to be set by probing the top of this and the center of this bore. Okay, so our width of our component is 2 inches 494 thousandths. So that's what we need to put in for our vise width. 2494. Okay, and there's our vise clamping our piece in. Okay, let's hit save. Now we're going to go back to manufacture mode. And we're going to create a new setup. Okay, on this setup, we're going to use as our stock, we're going to do from solid, and we're going to select the actual model of our part. Okay, so our actual part of the finished part is going to be the body. And our setup, we're going to use Z-axis and X-axis. So we're going to select top face of the part, and our X-axis is going to be in line with the edge of the hex that's lined up with our vise. We need to flip our X-axis so it's in the same orientation as this would be on our machine. We need to select our model. That's why we're getting a model box point. And it's also the part. And we'll go to model box point and select the center of our piece. Okay, we're going to go to post process. We're going to call this 7322. Program is going to be op2. If you want, you put in captions, 3-axis. And then we're going to use work coordinate system 1 because we're back in a vise with G54. And hit OK. Yeah, we're going to change the title of this to op2. Yeah, we're going to put some notes in. I'm going to right click on this. We're going to go edit notes. And note 1 is going to be work coordinate system G54 X, Y, Z origin is top center of part, machined part. Number 2, part to rest on parallel flat on throat of vise. 3, vise clamping pressure 10 foot-pounds. Okay, so now we're going to pocket the inside of this. We're going to use a 1/4 inch end mill. So go to 2D pocket. We're going to select our 1/4 inch end mill from our library. Okay, we're going to keep the default settings on its feeds and speeds. We're going to select the surface of the bottom of our pocket. We're going to go to Heights tab. We'll leave all this at default. We're going to go to the Linking tab, and we're going to select Morph Spiral. We're going to do multiple depths. Our maximum wrapping step down is going to be 0.125, half a diameter. We're going to do one finishing pass. That step down at the finishing at the bottom is going to be 0.01, 10 thousandths. We're going to do even step down. Okay, we're going to go to finishing passes. We're going to do one. We're going to use wear compensation. Our finishing smoothing deviation is going to be 4/10. We do one finishing pass. We're going to leave 10 thousandths for that cutter to remove. We're going to go back up to our maximum step over. 0.125, half the diameter of the cutter. Actually, let's do 100 thou. This is going to go pretty deep. Finishing feed rate's fine. We're not going to leave any stock. We are going to pick our smoothing on, and we're going to hit feed optimization so it slows it down on corners. We are going to finish at every depth because our cutter's not long enough to finish only at final depth, and we'll get a lot of cutter flex anyway. Okay, we're going to go to the Linking tab. We're going to leave all this at default except for our vertical lead-in radius is going to be 0. Our ramp type, we're going to switch to zigzag, and our maximum ramp step is going to be 125, and our ramp clearance is going to be 50 thousandths. And we're going to leave everything else at default. Okay, so there's our roughing and finishing cuts on the interior. Now the only thing left is we have a chamfer here and a chamfer here. So we're going to go to 2D chamfer. We're going to select from our library our 1/4 inch chamfer tool. We're going to leave everything at default there. Under geometry, we're going to select the inside hex, the outside of our boss, and the top of our 1/2 inch hole that goes all the way through. We're going to go to heights. We're going to leave all this at default. At passes, we're going to leave all this default except for our chamfer tip offset is going to be 0.06. We're going to check the smoothing deviation box. We're going to go to Linking tab. We're going to leave all this at default and hit OK. Alright, we should have our chamfers going around, and we've successfully now programmed the 7322 part.